Hello everyone, my name is Atul and I'm a senior DevOps consultant with over 15 years of experience in IT networking. Currently, I'm working with AWS, Azure, Docker, Kubernetes, Ansible, Jenkins, Terraform, Git, Maven, and many more tools. So I'm holding a certificate in AWS, Azure, VMware, and Kubernetes. So I have supported many big clients and set up their environment from scratch. And today we'll be learning about Kubernetes. And before learning Kubernetes, we need to understand why we need a Kubernetes, how environment is working before 10 to 15 years. So let's consider about what is physical server, what is VMware, what is container. So let's consider our first topic, what is physical topic. So in order to learn Kubernetes, first of all, we have to understand what is physical server, why we need Kubernetes in case the physical servers are already there. So in the right side, you will be able to see these are the physical servers. This is a group of servers, and these are the kind of physical servers. So in olden days, like 10 to 15 years back, when we have major companies like Lenovo, Dell, Cisco, HP, and IBM. So they are the major role player where we are getting servers from them, we are purchasing server from them, we are installing OS and running application on top of it. This is the only way by which we can run our application or expose our application to the external world. We have taken in one server from IBM and it's with a 10 CPU and a 5 GB of RAM. Suppose you wanted to install one application and its application requirement is a 2 CPU and a 2 GB of RAM. Okay, so but our actual CPU is 5, so we have given 5 CPU and we don't have any option. So right now our application is working perfectly. So this app is working perfectly, but out of 5 CPU, only 2 is required. So 3 CPU is wastage here. In the same scenario, suppose our application needs 2 GB to run an application, but 10 GB is available. So here we can say like 8 GB is wastage, which is not a very good way of to doing the same kind of task. So this is the drawbacks why physical servers are not used nowadays directly. So in order to fix this issue, a VMware come under picture. So this is the icon which maybe you have seen, but somehow in VMware we are able to fix this issue, but not 100%. So what happened? This is the same like a Dell physical server or maybe IBM physical server. On top of it, we'll be installing one VMware layer. And a server is same 10 GB of RAM and 5 CPU. So what we have done, so we have created four virtual machine, VM1, VM2, VM3, and VM4. So VMware gave us a facility to create a multiple virtual machine on the same physical hardware. So in the for the taking the benefit, we have taken created four VM1, 2, 3, and a 4. And out of on the top of it, we have created installed some application like app 1, app 2, app 3, and a app 4. So here the requirement is our app, suppose our application is taking 0.5 GB of RAM and but we have allocated 2 GB of RAM here. Here we have given one CPU, one CPU, one CPU, one CPU because we already have 5 CPU. So we have given one CPU, 1, 2, 3, 4. So 4 CPUs are used and RAM is 10. So we have given 2, 2, 2 and a 2. So 8 RAM we have already given. So in this scenario, what happens? 0.5 is the actual consumption, but we have given 2. So this one we can say this is not actual usage. And in case if we use this technology or VMware, then we'll be not able to utilize the resource. So nowadays scenario, what we are doing, like at least 80% or 90% of utilization we need it. It's not like something like 50%, 45 because we have already paid for that hardware. So in case if we paid for hardware, we want at least 9 GB we can utilize or 4 CPU we can utilize. So there are some major drawbacks of VMware. And what the drawbacks we want, we will be able to run only few resources. So there's a point one says we are able to run few resources only. And when we compare VMware with the physical boxes, so yes, we are able because right now we are able to utilize only two CPU and 2 GB. Here too much wastage, but here we have utilized some. But this is not 100% utilization or mean to say like good utilization. So, but here we are able to run only few resources, and this is a VMware because the licensing is costing, and it's very difficult to purchase license for all the players, especially startups. So, not everyone is able to afford the VMware licensing, and more cost is run required to run the same kind of resource. So, these are the major drawbacks. So, 2 point we already discussed. One is physical server, and one is a VMware. So now the third is containers. What is container? So whenever Docker container comes in, so we guys are working like thinking like a Docker container. So what is container? So let's continue about the theoretical part. A Docker container is a lightweight, standalone, and executable package of software that include needed to run an application, include code, runtime, schedule, system tools, libraries, and config file. Okay, so I'll be telling you like what is layman language. In layman language, what is containers? In layman language, containers are a lightweight software, or you mean to say lightweight package where we can install our application. So here we can take a consideration like Docker container. So this is a environment of Docker container, and this is a VMware. The way what we read in point two we have discussed, this is Docker container. So what is Docker container first? So Docker container is lightweight container where OS is already installed and we can run our application. So let's compare one by one. So what are their technology stack and stacks how things were installed in a Docker environment and VMware. So Dell server, here also Dell server, here host OS operating system. So any host operating system like Windows or Linux, anything we can install. So here also there. But here what we have done, we have installed a Docker layer. But here we have installed VMware. But in case of VMware come under picture, we have to create machines, only virtual machines like VM1 and VM2. So once we install virtual machine one is like something like first of all we need to install our entire OS, and then on the top of it we can install an application. So here the same thing VM2. So here we install the entire this OS and application 2. So this is the way what we have learned earlier. But here the Docker container. So here Dell server and here Docker. Out of Docker, you can see one small this rectangle box. So this is a virtual machine. We can say like virtual machine one. And here, let's I compared with this virtual machine. So here we can say this is the virtual machine and which lots of containers are running. So you can assume like this is a one container, this is one container, and this is one container, and all are utilizing CPU and memory of same virtual machine. So we can see how much congested it is. So we can create a multiple containers. Here, see, suppose in the same one we have created 5, 6, and this is called as a micro server, or you can say like a mini server in which we have a basic libraries, basic services which are required to run an application. You can say like a mini OS we have installed on it. So mini install we have installed on it and application we can run on it. And this is now used. Containers are running in with Kubernetes. So Kubernetes work with containers, either it's a Docker containers, Rocket container, LXC containers. So there are many containers are coming in the market, but we have to choose which one we require. So okay, so now we already discussed about this section. Now let's come about the container. So how it will be like we'll be discussing more on it. Suppose this is server and this is server, the same way what we have discussed over a Dell server, and then host operating system like a Windows operating system we have installed or Linux operating system we have installed. So next layer is hypervisor. So hypervisor here like a virtual machine VMware. Either we can use a Hyper-V or VMware we can use in this layer. In the third layer, we have installed a Docker. In the same fashion, we have installed Docker here. So after Docker, we have installed multiple applications like app A, 1, 2, app 2, app 3, app 4, app 5, and a app 6. So this is a way, so this is the major difference between a Docker and virtual environment is the layer, VMware and a Docker. Docker, because of Docker, we are in the same virtual machine, we can run multiple containers. That's why it's used. And some people will claim that why we are not able to install multiple applications the same way. Like application A, application B, we can install here itself. So the reason why we are not able to install because application have some dependencies. And the dependency, let's take an example of .NET libraries. Suppose in one application, uh, 4.4 is required, and in some application, another application B 4.2 is required. And in server, in case if one virtual machine, in case if we install two libraries, then one of application will create a problem. There are cases I've seen where applications are creating problem. And let's take another example, like IIS version. So suppose application A need 9 version and application B need version 10. If we install both of the IIS version in virtual machine, then what will happen? either during patching it will be creating problem, or some errors will be coming. It will sometime it will pop up upgrade from 9 to 10. So these kinds of errors you will be able to see sometime. So, and this is an isolated environment. Every container having their own libraries, basic lightweight libraries. So this is in a brief, we can say there's a difference. Containers is are good nowadays, and let's move forward. How can Docker containers look like? What are the internal contents? So, and this is a Docker, and this is the image of Docker. And how it will be like a one Docker container having Ethernet card, we can mount volumes, and it's having internal library. So this is something, and every container having their own IP address. Okay, and so this is Docker container. So in order to see like from microscope, we are checking some very tiny object. So in case if we see, so Docker container sometimes looks like this. Okay, this is all about containers, physical servers, and virtualization. Let's move to our lesson two, and